This is a Bosch Rexroth EFC5610 Inverter Drive, and this is a ctrlX Core X3. In this video, I'll show you how to set up the EFC5610 for EtherCAT so we can use the X3 to control it. Hello, I'm Simon from the Inverter Drive Supermarket. In the previous video, I showed you where to find the ctrlX App Store and how to install and license apps. Now we're going to put those apps to work. The first step is to configure the EFC5610 so it can communicate via EtherCAT. It doesn't include an EtherCAT connector as standard, but it can be added using the multi-Ethernet card and mounting module. Both are available from our website. I've included links to each product in the description below. The multi-Ethernet card fits inside the mounting module, which then attaches to the drive. Remove the two screws to open the module. Clip the card into one of the two available slots. Then reassemble and refit the screws. The module can be attached in place of the keypad. There are two screws to secure it, and the keypad then mounts directly onto the front of the module. I should mention that we're using a small EFC5610 in this demonstration purely for practicality. The setup and configuration are identical for higher power models, even those rated above 160 kilowatts. Once the multi-Ethernet card is fitted, power up the drive. Next, we'll change a few parameters to tell the drive to use the communication card for its run and speed command source. First, set B0.00 to 2 to allow access to advanced parameters. Next, set E0.00 to 20 to use the communication card for the speed reference. Then set E0.01 to 2 to use the card for the run command. And finally set E8.00 to 1 to select the card as the communication interface instead of the default of Modbus. We also need to change H3.40 to EC to select EtherCAT as the active protocol. However, the H3 group isn't available from the keypad, so we'll use software to do this next. We'll use IndraWorks DS, which you can download for free from BoschRexroth.com. Just search for IndraWorks DS and install the latest version. It's a large package with comprehensive help files, so it's worth including the help for EFC, VFC frequency converters when prompted. Once installed, connect the drive to the laptop using a mini USB cable. Then open IndraWorks DS. Select the Serial tab, choose the correct interface if you have multiple ports, and click Connect. Expand parameterization, then double-click Search Parameters. The software will read all parameters from the drive. Expand H3 and double-click H3.40, the requested Industrial Ethernet protocol. In the parameter editor, set the value to EC, then press Enter to save. We've now told the drive to use EtherCAT, but it won't take effect just yet. The active Industrial Ethernet protocol shown in H3.41 has not been updated, and it won't update until after a power cycle. Close IndraWorks DS and disconnect the USB cable. Power cycle the drive, then reconnect the USB cable, and reopen IndraWorks DS. Connect as before, expand parameterization, then double-click Search Parameters. Then expand H3, double-click H3.41, the active protocol. It now shows EC. Perfect. That means EtherCAT communication is active, and we can now close IndraWorks DS and disconnect the USB cable. With the EFC5610 configured, we can connect it to an EtherCAT network. In this example, we'll link it to the ctrlX Core X3. Use a shielded Ethernet cable from either multi-Ethernet port on the EFC5610 to the XF50 port on the X3 or to the out port on a bus coupler. And that's it, the drive is now physically connected. Before we wrap up, let's take a quick look at how the EFC actually communicates over EtherCAT. Every EtherCAT network needs at least one master and one or more slaves. In this setup, the core X3 is the master and the EFC5610 acts as the slave. Communication between them follows a device profile, which defines what data is exchanged. The default profile, Rexroth mode, has 4 standard values: control word, status word, frequency command, and setting frequency. These are documented in the EFC manual, and it is possible to add to them if required. The control word is a 16-bit instruction sent from the master to the EFC. It tells the inverter what to do, like run, stop, or reset fault. In return, the status word is a 16-bit response sent from the EFC to the master. It reports the current state, running, accelerating, error, and so on. The status of each bit can be viewed in IndraWorks DS if needed. Simply expand the monitoring tab, select Field Bus, and open the links to status word and control word. Alongside these, EtherCAT also transmits the frequency command. This is the target speed that the master sends to the EFC. It's also a 16-bit value, but in this case it represents a scaled numerical value corresponding to the desired output frequency in hertz. The EFC then returns the setting frequency, a live, continuously updated reading of parameter D0.02, again as a 16-bit value representing a scaled number. Together, these signals allow for real-time command, status monitoring, and speed control between the X3 and the EFC5610 over EtherCAT. In a later video, I'll walk you through reading and writing these values inside a ctrlX PLC so you can run the EFC directly from the X3. That's it for this video. In the next one, we'll configure the EtherCAT Master inside the core X3 so it can recognize and communicate with the EFC5610. Thanks for watching. If you found this helpful, please give it a thumbs up and consider subscribing. It really helps support the channel. See you next time. This video is for educational purposes only. Always follow official manufacturer documentation and safety instructions.